not be the same.
A nuclear weapon is the most powerful kind of explosive ever created. Unlike conventional bombs, which rely on chemical reactions like burning TNT, a nuclear bomb taps into the energy stored inside atoms. This is called nuclear energy. You have probably heard of Einstein's equation, E equals to mc square. It means that a tiny bit of matter, when converted, can release a huge amount of energy. Nuclear weapons use this principle in real life. There are two main types of nuclear bombs: fission bombs and fusion bombs. Fission bombs split atoms of uranium-235 or plutonium-239. When these atoms split, they release energy and more neutrons, which go on to split even more atoms. This is called chain reaction, and it happens in a fraction of seconds, releasing a massive explosion. Fusion bombs, also called hydrogen bombs, take it further. They start with a fission explosion, which then causes hydrogen atoms to fuse together, just like in the sun. This fusion releases even more energy, making hydrogen bombs many times more powerful than the ones dropped on Hiroshima and Nagasaki. To build a nuclear bomb, you need special radioactive materials. Uranium-235 is one, but it's rare and has to be separated from the more common uranium-238 using giant machines called centrifuges. Plutonium-239, on the other hand, is made inside nuclear reactors and then extracted chemically. Either way, getting these materials is extremely difficult and expensive. On top of that, the bomb itself requires precise explosives to compress the core, special initiators to start the chain reaction, and very advanced engineering to make it all work exactly at the right moment. The cost of developing the first nuclear bomb was enormous. During World War II, the United States launched the Manhattan Project. A top secret involving over 130,000 people, multiple secret facilities, and some of the greatest scientists of the time. The project cost $2.2 billion in the 1940s, which is over $30 billion today, just to build the first few bombs. That's more than the cost of building entire cities. And what did all that lead to? On August 6, 1945, the US dropped the first atomic bomb on the city of Hiroshima, Japan. The bomb was called Little Boy. It used uranium-235 and weighed around 4,400 kilograms or 9,700 pounds. Inside, it carried just 64 kilograms of uranium-235, about the size of a football. But only a small percentage actually fissioned. Even so, it releases an explosive force equal to 15,000 tons of TNT. 3 days later, on August 9, the second bomb, Fat Man, was dropped on Nagasaki. This one used plutonium-239, weighed around 4,670 kilograms, and exploded with the force of 21,000 tons of TNT. The results were devastating. Over 200,000 people died between both bombings, either instantly or within months from burns, injuries, or radiation sickness. Survivors, called hibakusha in Japan, suffered long-term effects like leukemia, birth defects in children, chronic illness, and trauma that lasted for generations. Even today, some areas around Hiroshima and Nagasaki maintain radiation monuments, survivor hospitals, and peace museums to remember the event. Though radiation levels have long since dropped to safe levels, the psychological and cultural impact remains. Japan became the only country to experience a nuclear attack, and that legacy still happens its policies and peace movement. So how dangerous are nuclear weapons? extremely, not just in their explosive force, but in the invisible radiations they release. Fallout can poison land, water, and people for decades. Some nuclear test sites like Bikini Atoll or parts of Nevada, they are still unsafe today. Chernobyl and Fukushima were not bombs, but they showed how nuclear accidents, even peaceful ones, can devastate entire regions. But are there any positive to nuclear technology? Actually, yes. If used carefully, the same science that powers bombs also powers nuclear reactors, which provides about 10% of the world's electricity, and do so without releasing carbon dioxide. Nuclear energy is used in submarines, aircraft carriers, and satellites. In medicine, radioactive isotopes are used to kill cancer cells or scan the human body. Even agriculture uses nuclear science to improve food safety and pest control. So while nuclear weapons are destructive, nuclear technology itself has a wide range of peaceful uses. Now here is the final question. Why do we always compare nuclear explosions to TNT? TNT stands for trinitrotoluene. It was actually invented in the 1860s, not as a bomb but as a yellow dye. When scientists later discovered its explosive potential, it became widely used in war and construction. The reason TNT became so popular is because it's stable. It won't explode until triggered by a special detonator, and it can be melted and molded into shapes. Because it was used in so many military explosives, it became the standard for measuring all kinds of blast. 1 ton of TNT releases about 4.18 billion joules of energy. So when we say a nuclear bomb has the power of 15 kilotons, we mean it's like 15,000 tons of TNT going off all at once. That's why we still use TNT as the benchmark. It helps us grasp the unimaginable scale of nuclear explosions. So now you know nuclear weapons are not just oversized bombs, they are machines of unimaginable power born from the tiniest parts of matter. Their impact reaches far beyond the battlefield, shaping politics, science, and the world itself. Understanding how they work gives us the power to think critically about how and whether they should be used. Because in the end, knowledge isn't just power, it might be the only real defense we have.